Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel where we talk about everything I want to, science and math. And today we are in chemistry class, and we're going to be going over how to do calculations that have to do with molarity. So what I do as a chemist a lot is I make solutions. I go back to my stockroom, I get some powdered chemical, I weigh it, and then I add water and I make a solution for us to use in lab. But I can't just add, whatever I feel like. I have to have a certain concentration. And to know the right concentration, I use my periodic table and I do math. So now you're going to learn how to do the math too. So the key to understanding this math is to understand the definition of what is this big M. Okay, what is meant by molarity? So the definition is that if something is 1 molar, you have added 1 mole of it to 1 liter of solution. So that's the big thing to know, that a 1 molar solution has 1 mole of stuff, of solute, added to 1 liter of solution. And then, and it doesn't matter what it is, that's the definition. Okay, so this is an example thing. If I was going to make a 1 molar solution of salt, sodium chloride, step 1 is you always have to get the molar mass. And remember, our symbol for molar mass is M&Ms. Where do you get M&Ms? Off the periodic table. Well, you probably really get M&Ms at the store. But if it's molar mass and not M&Ms, you look on your periodic table. So what I do first is I look up sodium and I find the decimal number, and that's the molar mass of sodium. And then I look up chloride and find the decimal number, and that's the molar mass of chloride. Sodium chloride doesn't have any subscripts, the little numbers at the bottom, so I just add them together, and the answer is 58.44 grams. Now, my students are going to ask, how far do we have to round this? And on this worksheet, I kept 2 decimal places. The test on Friday will be multiple choice, and you don't really have to worry. You could probably round it to a whole number and get the right answer and find the answer on the multiple choice test. And I know some of y'all who don't have me are going, oh, that's too easy. But now you're sad that you don't have me, because I would let you round it off to a whole number. Unless this one, chlorine, is too far to round, keep it 35.5. Halves, keep halves. All right, so step 1, add up the molar mass. Step 2, you are going to multiply the molar mass times the volume and the concentration. Okay, so that is basically how you do all these problems. So to get the right amount to go way out, you multiply it by the volume and the concentration. Now, what makes this tricky is instead of writing 1 liter, Dr. Phelps, who made this worksheet, give her credit there, she used decimeters cubed, which is the same thing. And instead of use a milliliter, she used centimeters cubed, which is the same thing. So don't let that confuse you. So if it was just 1 molar that I was making, I would put 58.44 grams into one of these things called a volumetric flask. I would use a liter one, not a 500 milliliter one. And I would put it on the scale. I'd hit tare, and then I would add 58.44 grams. And then I would fill it up to this. There's only one little etched line on a volumetric flask, and you fill it up to the bottom of the curve touches the line. That's called the bottom of the meniscus. That's fun to say. And you fill it up, and then you shake it or stir it or put it on one of those stirring hot plates that's got the little woo 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 bar. Some more fun with sound effects. And you make your solution. But often, when I'm teaching chemistry, I don't need a whole liter. That's a lot. Usually, I use less. And sometimes, often, I don't need 1 molar concentration. I could need more or less. And if you remember a lab we did with hydrochloric acid in my class, we used 3 molar and 6 molar, not 1 molar hydrochloric for that reactions lab. Okay, so that's all the background information. So this is how you do the problem. You look up the molar mass, and you can actually do this 2 ways. So I'm going to show you the first way. We want this to be 1 molar. So I can set up a ratio like how we do in math, and I could say as 58.44 is to 1 liter, X, what is it if I just want 100 milliliters, which is 0.1 liter. how you can do that is King Henry's Daughter bakes delicious chocolate muffins. I'm at milliliters and I'm going to basic. So I go 1, 2, 3 frog hops. I would move my decimal point 1, 2, 3 times. So it's 0.1. To cross multiply, I do 58.44 times 0.1 equals, put it on one side, and on the other side, 1 liter X is on the other side. You would divide both sides by 1, but of course anything divided by 1 is itself. And so the answer here is 5.844. An easier way to do this for these problems is you look up the molar mass and you multiply it by the amount and the concentration. So I would do 58.44 times 1. Don't really have to do that because anything times 1 is itself, but just to see how. And then multiply it times this, but we'd have to change it to liters first. It would be 0.1 liters. So you would do 58.44 times 1 times 0.1, and the answer is 5.844, and the amount is, once you write down, is always just the amount in the problem. So there it is. 0.1 deciliter or liter. Okay, so here's another one. This time we want a whole liter. So remember, this is a liter, but we want 3 times as concentrated. So we would take this and multiply it times 3. 3 times the molar mass is the answer. But once again, it works. This number times 3 times 1 is that. And this is that amount written right there. So here, first number 1, we could just write that amount right there, the volume. And now to get what they want, we would take our molar mass, and see it's still sodium chloride, times 0.1 times 0.5, and there's the answer. So 0.1 is a tenth. So here I did it with dividing instead. I did 58.44 divided by 10 equals divide by 2, because 0.5 is a half. I think multiplying is easier. Just take whatever your molar mass is, multiply it times this, multiply it times that. So now we have a different solution. So we have to go back and get the molar mass, the mass off the periodic table, the mass of sodium plus oxygen plus hydrogen. We add them up and it's 39.99. So this is 100 cubic centimeters, so we're going to change that to liters. That's 0.1 liter. We'll draw an arrow down there. Okay, so we would just do this number times 1 times 0.1, and it's 3.99. And our solution is 0.1 liters, and we do that by King Henry's Daughter makes delicious chocolate muffins. We could do it as a cross multiply, or we could just multiply them. So here's another one, sodium hydroxide. This one is 1 liter. That's the same thing as 1 liter. So we would do our molar mass times 1 times 3. There's the answer. So here's another one. Sodium hydroxide, we do our mass times 0.5 times 0.1. There's the answer. You could also do it by dividing, because that's a tenth and that's a half. But I think it's easier if you just always do it the same way, multiplying. Okay, here's another one. This time we changed our chemical to calcium chloride. So look up calcium, look up chloride, but that little 2 means I have to multiply the mass of chloride by 2 to get my molar mass. So it's 40 plus 35.5 times 2, enter 111. Okay, so I'm going to do 111. I changed this 300 milliliters to liters by doing 3 frog hops. Woo. So I'm going, so don't let it confuse you that this is C. Remember, 1 centimeter cubed equals 1 milliliter. So I'm going to start with milli and go to basic. So I go 1, 2, 3. That is 0.3 liters. So I'm going to take my number times 0.3 times 2.2. There's the answer, and there's my volume in liters. Okay, this time I take my molar mass times 0.3 times 1.5. There's the answer. 1.5 is the volume. This time I take 111 times 0.18 times 0.05. There's the answer. There's the volume. This time, once again, we have to change it into liters. So it is the molar mass times 6.3 times 0.425. There's the answer. These are easy, aren't they? Okay, let's look at the back side. Okay, now this one, instead of having to figure out what it is that, what I need to put in my flask to make it. This time I have a solution and I want to figure out what is the concentration, what is the molarity. Okay, so this time what you do is you start with what you know. I always make everybody say that in class, so I'll pause for y'all to say it. And what we're going to do is you write what you know first. And they tell us that we have 68 grams in 500 cubic centimeters. That's 500 milliliters, which is 0.5 liters. So that's what we know. That's grams per liter is what you start with. Now, I want to get rid of grams and have moles. Where do I learn how to do that? Our friend, the periodic table, by the molar mass. We need our M&M. So I'm going to add up the mass of nitrogen plus hydrogen times 4 plus nitrogen plus oxygen times 3. And the reason why they put those two nitrogens in two different places is they are reflecting the structure of this molecule in the way they're writing it. Don't let that confuse you. So I just add them all up and I got 80. So now remember, whatever unit you have in the numerator, it's more fun with sound effects, goes down to the denominator. And what number goes with this grams is our molar mass 80, and that's grams per mole. So what goes on the other side of the fraction bar? The mole, that mole right there. There it is. The grams cancel out, and I'm left with moles per liter, which is the units of molarity. And you multiply everything on top, divide on bottom, but you don't have to bother with ones. So it's 68 divided by 0.5, enter. Divide by 80, enter, and there is the answer. So that's what we do with all of these. So this time we're given 8 in 0.225 liters, because remember that's the same as liters. We put our grams on the bottom, we divide, there's the answer. Do it again. We're going to do this problem over and over. Here's our amount to start with. That's the amount we've got, 1.5 liters. 80 is still the molar mass. This time we have 1 gram, we have that many liters, 80 is still the molar mass. Now they say rank these in order. So we look at these 4 numbers and say, which is the smallest? Well, that one's the smallest. So this is the least concentrated. That's the next smallest. That's the next smallest, and that's the biggest. All right, that was easy, wasn't it? This is going to be a great test. We're going to have lots of hundreds. All right, like, share, subscribe. Science is great.